Alrighty, this is going on page 45 when we're done. Yesterday we talked about arithmetic sequences. Today we're going to talk about geometric sequences. So yesterday we kind of threw all the sequence stuff out, didn't really even pay attention to all the a sub n's and a sub k's and things, and just use equations of lines. And hopefully that will help you understand it and remember it a lot better. I don't have anything as leading for this, but I think we can get through it without still having to worry about the n's and the k's and stuff, and that being too much for us to remember in the end. Because again, it's not difficult, but we're not going to use it a lot. And we have a lot more of important things that really need that space in our brain, but we've got to tuck this away somewhere where even if we review right before, but we don't use it much, that we can pull it out of our little filing cabinets and make it make sense to ourselves. All right, so our geometric sequences. So your property of successive terms, so it'd be something like 1, 2, 4, 8, 16, and so forth, okay? So your successive terms, one right after another in a row. Thank you. Just one person. Okay, got it, thanks. Here you go. Your successive terms, instead of having a common difference like yesterday, they have a common ratio, which we show as R, okay? Common ratio. That means that is a constant proportional change, which means instead of adding the same number over and over again, we are multiplying by the same number. So we multiply each term, previous term by 2, that's how we get the next term. Okay, that makes sense? Good on that. All right, so then we have our little formulas. And knowing what we know already about exponentials, because this is geometric is tied to exponentials, our arithmetic is tied to linear, and this is leading us into the exponential stuff. Exponentials are not brand new to you. You first start them in Algebra 1. Your most basic exponential is y equals a times b to the x power, okay? Where a is your initial amount, okay, because we do this a lot with money, like if you're going to invest money or whatever, that would be like your initial amount. And then b is your multiplier. It's your ratio. It's what we would use as r right here. Okay, but that little format, that parent function, is something that should already be floating around in your little brains in some way. Now, when we look at these two formulas that we have for geometric sequences, this first one is kind of like our y equals mx plus b, and this one's kind of like our point slope form, where if you had to know just one, it would be the second one, and that's kind of how we're going to tie everything together. But I'm going to avoid all the n's and the k's because I think that's what throws everybody off, and we'll get you there a different way. But we kind of still need to understand what all this stuff means. If I look at this versus this right here, this g sub 0, that's your a right here. That's just your initial value. That's all it is, just like it has always been. Okay. And then your r is your b right there, which is your multiplier or your common ratio. All right. And then your g sub k, just like a sub k yesterday, that's your kth term, which is a very strange thing to say. That's the output that you know, okay? So for our x and y's, or for our functions that we're used to, this is an xy relationship. For our sequences, this isn't, your input is n, your output is g sub n. Just like yesterday, our input was n and our output was a sub n because it was arithmetic. This is g for geometric, okay? So that's how our little ordered pairs work. Then, just like I've said already, geometric sequences behave like exponential functions, but they are not continuous. So again, this is discrete data. We are not connecting the dots because it's a list of numbers. And increasing geometric sequences increase by a larger amount each step, where in arithmetic, they increase by the same amount. Since we're multiplying by something, this increases by 1, then by 2, then by 4, then by 8. So every step, it increases more. That's for increasing functions. If it's decreasing, then it would be decreasing by more, that sort of thing. Okay, everybody good so far? All right, so here's a little equation that we have. And we'll talk about this a few different ways. First of all, this matches that, it matches this form right here, where we can have, that means from here that G sub 0 is equal to 6. Right? What I really want them kind of all to match is this one, without us worrying about our N's and K's and everything. So for it to match that one, for us to make sense of it so that everything is consistent, if I make it look like that, then I'm just going to put N minus 0. So instead of N, it's N minus 0. Or it might be N minus 1, if it, depending on what it is. So that way, to get my ordered pair, I can get an ordered pair from a statement like this, or my ordered pair is whatever's being subtracted from N. N is your input, so that's 0. And then whatever number right there is my output, and that is one ordered pair on my graph. Which even if I didn't write it with the N minus 0, that sort of thing here, I would still know that that's a point on my graph, because since this was just N, that is my initial amount. So just to be clear, that number is only the initial amount if this is just plain old N right there. If it was N minus 2, whatever number that is, not the initial amount, but it would give me an ordered pair. Okay, you with me on that? So we're not so worried always about the initial amount, more about trying to find an ordered pair. Because I want it to be in this form. I want you to only have one form that you have to think about. And so I want this to be the form that you're thinking about. And in order to make this match this, your K is just 0, basically. So we're just making it, we always set them up that way. We have one way to do it and not multiple ways to do it, which usually is what causes confusion. Because you're like, do I do it this way? Do I do it that way? What does this mean? That sort of thing. If we think about it like this, then whatever number this is my input, whatever number that is my output. If this number is 0, then this is my initial amount. It's like my y-intercept. Okay, does that help? It's a good question. All right, so 0, 6. I'm gonna plot that point. Okay, and then even though we don't necessarily need to, we're gonna make a little t-chart over here. N and G sub n. So we started with 0, 1, 2, 3, dot, dot, dot. So 0 we know is 6. And then if I want G sub 1, that is 6 times 1/2 to the first power. It's 1 minus 0, but over here I don't have to write all that. So that's really just 6 times 1/2, which is 3. G sub 2 is 6 times 1/2 to the second power. What's that going to give me? 6 over 4, which is what? This is 6 times 1/4. Be 3/2. Because what am I multiplying by on each step? 1/2, right? 6 times 1, because that's my R. 6 times 1/2 is 3. 3 times 1/2 is 3/2. 3/2 times 1/2 is what? 3/4. Okay. So there's my little points that I can plot. I'm going to go to 1, 3, 2, and then 3/2 is like 1.5, and then 3 and 3/4. I'm right there. Do I connect the dots? No, because this is discrete data. You are more likely to get a graph and have to pull things off of it than you are to have to graph it. I mean, I can tell you for a fact on the actual AP exam, you're not going to have to graph anything. You're not graphing is not part of it. Writing some stuff on some graphs is, and we'll talk about all that. But for us to understand it, we need to be able to do it both ways. Okay. What questions do we have? Anything? All right. So now we are going to determine if the sequence could be geometric. If yes, we're going to identify the common ratio. Okay. So geometric sequences behave like what kinds of functions? Exponential. All right. So I look at A. That's a function. I mean, I kind of recognize that as a function. Is it an exponential function? No. Just because it has an exponent doesn't make it an exponential function, or every polynomial we've ever talked about would be an exponential function, and that doesn't make any sense. So this is not geometric because this is not exponential. Okay, that makes sense? So now let's look at B. Is b an exponential function? Yeah. Yes. So then is it a geometric sequence? Yes. So this is geometric. I need to identify the common ratio. What is that? 2. Okay, it is 2. All right. It's whatever number's in the parentheses. Now, it doesn't technically have to be in parentheses. I think most of the time you'll see it that way, but it could be written just like 4 times 2 to that. So not necessarily. I think when you write it, you should totally put parentheses so you're saying what you're trying to say, but sometimes it's not typed that way. Now, it did not ask me for this, but we're going to write it down. From this, I don't necessarily know my initial value by looking at it, but I can give you 1 point on that graph. Okay, my input is n. The number after n is 1, okay? And the n is like an x, so it's a liar. So it's n minus 1, so my input is 1. What would my output be? 4. That's where I get that ordered pair from. 1, 4 is one of the points in the sequence. And then from that, knowing r, I can find every other point that exists. You with me on that? So you see how to use that? Whether we know what's a k or whatever, nobody cares, okay? Doesn't matter at all. We good? All right. Yeah? Okay. Now on the next two, and on your assignment, all these are together and it says, state if it could be arithmetic, geometric, or neither. So on ones like C and D, you got to check one. If it doesn't work, then you got to check the other. Okay, so yesterday we checked to see if they were arithmetic by subtracting them, right? Looking for a common difference. Here we are looking for a common ratio. So I make a ratio of the second over the first. So I put 3 over 1 and I get 3. Then I put 2 over 3 and I get 2/3. Are those the same? No. So then I don't have to go any farther, right? And I can just say that this is not geometric. And me finding 2 of them basically is my proof. Like I just showed you, they're not the same. So there you go. So you subtract for arithmetic, you divide to find the ratio for geometric. So here I'm going to take -8 over 16, that's -1/2. 4 over -8, that's -1/2. Those two are the same, but I don't get to stop because maybe the next one isn't. Like I have to do them all, I have to keep going. So that's also -1/2, that's also -1/2. So of everything that they gave me, and that's why it says could be, because maybe my next term is 5 and that doesn't make any sense. But in here, yes, it's geometric. So I can say that it is geometric and that r equals -1/2. And if you don't divide correctly or you don't subtract correctly, then your common difference in your ratio numbers are just wrong. Okay. What questions do we have? Anything? Okay. So here we've got G sub n is a geometric sequence. They give us one term and they give us the r value. Again, like yesterday, I have 2 questions to answer here. I need an expression for G sub n and I need to find G sub 4. So here's how easy your G sub n is. We need r and we need 1 point. So I'm going to take this and change it into an ordered pair just like we did yesterday. That would be 112. Okay. And remember that this is n G sub n. That's the ordered pair there. Okay. So when I go to write my G sub n formula, the first number I write down is my output. It's that 12. I get 12 times, and then the r value, which is 2. Then my exponent is n minus whatever the x value is right there. There's my equation. So if you know what a parent function of a exponential looks like, and you know that that's basically how everything works out, we don't have anything plus at the end, there's no vertical shift or anything, that this is what we have, and just know where to put those 2 numbers is going to be a piece of cake. Okay, we good on that? All right, so now that's my G sub n. So now I got to find G sub 4. So that's going to be 12 times 2 to the 4 minus 1 power. So that's 12 times 2 to the 3rd. What's 2 to the 3rd? 8. And 12 times 8 is 96. Okay. What questions do you have? We all good? Okay. All right, so now it says several terms of the geometric sequence G sub n are shown above. Find the expression. So again, I need to find a G sub n. I'm going to find G sub 10. So I can pick any of these points on my graph that I want to. I would totally not pick any of these because I feel like I'd have to guess at what they are. So why make my life more difficult? Why not pick this point right here? Kind of like picking my y-intercept, right? So my ordered pair is going to be 0, 8. Then I need to find my ratio. So unlike a line where I can pick literally any 2 points and find the slope, even though it's easier to do the 2 right next to it, I have to use consecutive points. So I can use these 2 here, or I can use the one that goes with 1 and 2. It doesn't matter. But this output is 4. This is 8. So 4 over 8 gives me 1/2. And then I can see that I take 8, multiply it by 1/2, get 4, multiply it by 1/2, get 2. So that makes sense right there. And I've got that 1/2. Okay. Everybody good with all that? All right, so then I've got my G sub n. I take the output of my ordered pair, that's 8, times my R value, to the n minus input 0. Do you have to put the n minus 0? No, you don't. But again, I think a lot of times it helps if you're consistent, right? So that you don't just think that you don't ever have to put anything there. Because if you wrote it like that and the answer key just said n, still the exact same thing, 100% fine. Okay? We good? All right, so now I got to find G sub 10. So that's going to be 8 times 1/2 to the 10th power. No need to write 10 to the 0, 10 minus 0. So this is going to equal 8 times 1 over, all right, 2 to the 10th. So we got 2, 4, 8, 16, 32, 64, 128. 128 times 2 is what? 256 times 2 is 512 times 2 is 1024. You're fine. Okay, so that gives me 8 over 1024. Now, I could actually do the division. I have no desire to do the division. If you already know what the answer is, that's great. Just hang on to that in your brain because I think most of us in here probably don't just know it. If this were me, or literally how I would do it for myself, I just start reducing. They're both even. So that would give me 4 over 512. Then that gives me 2 over 256. Then I divide them both by 2 again. I get 1 over 128. For me, that's way faster than actually doing division. It's just kind of marking it down a little by little. Okay, you get 1 over 128. What questions we got? Anything? All right, good deal. And the other thing is on stuff like this, if you actually go and do division, what I see a lot of times is you do the division, you get 128, and then you say your answer is 128, not 1 over 128, because you went off to the side and did division, and you're not really thinking about what you're putting back in, so just be careful. Okay. Any questions at all? All right. So the first part of the back kind of repeats a lot of stuff because this was like a second day thing that depending on, where time fell. But so just like we said before, we got a geometric sequence, common ratio. Each term is multiplied by the same number. And this is generally our general form. We don't care about the k's and stuff. All right. So we're going to write, once again, what would this ordered pair be here? 3, negative 3. And then your R is 10. All we have to do here is just find the G sub n. So what number goes first? Negative 3. And then what goes in parentheses? 10. And then that's to the n minus 3 power. Okay, you get the hang of that? It's fairly simple, right? If you don't practice it, you're not going to remember it. Even when it's easy, you got to practice it a little bit so you can get the hang of where you're putting stuff, right? All right, you do example 2 on your own, or you can do it with your group and talk about it, make sure you agree and whatnot. Do you agree with my G sub n formula? Yes? Okay. So then I want G sub 5, 24 times 1/2 to the 5 minus 2 power, which is 24 times 1/2 cubed. So that is equal to 24 times 1/8, which gives you 3. Okay. Any questions at all? Everybody understand where everything comes from and why we're putting it where we're putting it? Yes, we got it. Okay, perfect. Okay, so these examples that we just did, they're pretty straightforward because they gave you a term and they gave you the common ratio. However, how can we deal with problems that give us 2 terms but not the value of r? So this is like on a line where we had to find the slope before we could just write the equation of the line, right? Way easier if they actually gave us slope. So there's some little instructions on how to do it, but I'm just going to take you through it. Okay, so we're going to deal with this kind of the same way. We've got G sub n, and then I have 2 terms, so I'm going to make both of those into ordered pairs. All right, and then I'm supposed to find G sub n and G sub 11. So again, I've got 2 parts to this question. So the first thing that we're going to do is just write a G sub n formula pretending like we know what r is, right? And to do that, I need one of those 2 points. And just like with a line, it makes absolutely no difference which one I use. However, to make your life easier so that you don't end up with negative exponents in what you're doing, when you have these 2 things, choose the one that has the smaller input value. The negatives aren't as much of a problem here, but you got to just trust me on this. I'll kind of show you when we're done, but it's not wrong if you use the other one. You're just going to make something a little bit harder on yourself. So it's usually going to be, just choose the first one you see. So this is the one I'm going to use to write my G sub n. So I do G sub n is equal to my output, which is -2, times r, which I don't know, to the n minus 3 power. Okay, so we just did it basically just like we've done everything else. We just don't know what r is. So now we're going to use the other equation to help us figure out what r is. There's a reason I didn't put it in all at once. The reason I didn't put it all at once is, first of all, it can make you put numbers in the wrong spot, but also this kind of solidifies which one I'm really using in the equation in the end. This one I'm going to use just to help me find r. So this is, I have n and G sub n right here, so I'm going to label those so I don't do anything weird there. And then I'm going to substitute that in. And I'm going to, so for G sub n, that is 128. That's equal to -2 times r, which I still don't know, to the 6 minus 3 power. If I had used that ordered pair first, then that would give me 3 minus 6, and I'd get a negative exponent there. And then I'm making things more difficult when they don't need to be. That's why you want to start with the smaller one. All right, so then I need to divide, right? Because I'm trying to get r by itself. So I'm going to divide by a -2. What's 128 divided by a -2? -64. And that's equal to r cubed. Now, I don't want r cubed. I want r. How do you undo a cube? Cube root. So r is equal to the cube root of a -64, which you can also write as -64 to the 1/3 power. Just want to remind you that fractional exponents exist. They mean the same thing. We can't be afraid of them, all right? What happens when I take the cube root of a negative number? It just becomes negative. The imaginary only happens with a square root, but with a negative, negative times negative times negative is still negative, right? So if you take an odd root, your answer is just negative. So r would equal negative, and then what's the cube root of 64? 4. You only have so many things you can choose from, right? I mean, 5's an easy one to do. 5 times 5 is 25. If you have 5 quarters, that's $1.25. So clearly it's less than 5, right? You don't have that many to choose from. And once those numbers start popping up over and over again, you'll recognize them. So there's my r. So now I'm going to come back over here and use this and put r back in there. So G sub n is equal to -2 times -4. This is why the parentheses are important, to the n minus 3 power. There's my G sub n. Now I also need to find G11. Okay, so that's -2 times -4 to the 11 minus 3 power. What's 11 minus 3? Oops, 8 to the 8th power. Okay. Now, I'm not going to make you do negative 4 to the 8th power, but I do want to ask you, when I take negative 4 to the 8th power, what's something you can tell me about that number? I don't care about the actual. It's going to be positive because I'm taking it to an even exponent, right? After I take it to that even exponent, then I multiply it by a negative 2. So my answer is actually negative, okay? And this is a big number. Are you capable of doing it? Yes. Is it worth our time? Absolutely not. 131,072. Okay. You might have to, on the non-calculator section, deal with something on the front like we had where we had that fraction at the end. But a number that big, nobody's testing your multiplication skills. So that's why I'm just going to give it to you. But you shouldn't get any more numbers that huge. Okay. We good? Questions? All right. So let's do another one. Here are my 2 points. So I'm going to write them out as 248 and 7 1.5. And then go ahead and write your first G sub n. I would do 48 times r to the n minus 2. Do y'all agree with that? Yes? Okay. So then I'm going to make this n and G sub n. So this will give me 1.5 equals 48 times r to the 7 minus 2 power. Okay, 2 things here. That 1.5 is going to make my life way easier if it's a fraction. What is 1.5 as a fraction? 3 halves. So I got 3 halves equals 48 times r to the 5th. Okay. So now I need to divide by 48. I don't want to make this a fraction and a fraction. Dividing by a number is the same as multiplying by its reciprocal. So if I divide both sides by 48, it's the same as multiplying both sides by 1 over 48. So if I do 1 over 48 times 3 over 2, that would equal r to the 5th. Then here, if 3 goes into 3 once, goes into 48 16 times. So that'll be 1 over 32 is equal to r to the 5th. So then r is equal to the 5th root of 1 over 32, which will be 1 over something. What number times itself 5 times is going to give me 32? What's the only thing that even makes sense to try? 2. 2, 4, 8, 16, 32, right? I mean, trying 5 or 7 or what, those numbers get way too big, way too fast. So it's 2. It's 1/2. Oh, sorry. R is 1/2. Throwing things at you. Okay. So go ahead then and find G11. Oh, I'm sorry. Before we do G11, oh, I skipped ahead. Don't find G11 yet. We have to write our actual G sub n. Coming back over here, right? That's equal to 48 times 1/2 to the n minus 2 power. Always make sure you answer the questions being asked. Now that you have that, now find G11. I'll get 1 over 512. I missed a number earlier today. 2, 4, 8, 16, 32, 28, 256, 512. Yeah, that's 9. So that gives me, that's 48 over 512. And then we would just reduce. I just cut it in half. 24 over 256, 12 over 128, 6 over 64, 3 over 32, and then I can't go any farther. Of course, you can totally reduce different ways if you see the numbers. Some of y'all I know can like manipulate numbers in your head greatly, but I think that process probably helps a lot of people that struggle with that. What questions do we have? Anything? We all good? All right. You have your assignment from yesterday, so now you can do all the rest of it. You're good to go. All right?